Hello, everyone. I'm Everton de Oliveira from the Groundwater Project. And we're pleased to tell you that we're releasing a very new book, and it's very good. I was telling the authors here that I missed that book when I was a student. This is very handy, because you have all the pieces together. The book is called Flow and Distribution of Non-aqueous Phase Liquids, the famous L NAPOs and D NAPOs. For those who know the stuff, is a good reading because put things in place. It's just a single, easy to read book. I do recommend you download the book, tell your friends, and have fun reading it. It's very interesting and you have nice illustrations. I think the authors did a great job, and I would like to congratulate them all for that work. So before we go into that, please remember telling your friends, downloading the book. If you download the book, you're doing a great favor, even if you don't read. I know you will read, but even if you don't read, your download counts on Google. And that's good for us because groundwater goes up on the searching engines, and that's very handy for us. So make groundwater more important by helping us clicking on our books and bringing your friends to the website. Don't just distribute from a copy from yours. Come to our website so you help groundwater becoming stronger. So thank you very much. Now I have the pleasure to introduce you to the authors. The first author is Kevin Mumford. He's an environmental engineering MSc in civil engineering from the University of Waterloo and a PhD in civil from McMaster University. He's a professor at Queen's University since 2010. And I just learned that he was a student of a great friend of mine. Very good. I have here Bernard Cooper, and I would like to say Bernard for the first time because I always call him Bernie, like everybody else, I guess. He's a professor at Queen's University. He's a popular short course instructor, a great one, I may add, who has lectured on the topic of DNAPO and LNAPO migration and remediation in course held in Switzerland, Australia, Denmark, England, the United States, Brazil here, and Canada. And finally, but last but not the least, Bob Leonard, Robert Leonard, let's put the full name. And he studied under doctors A.T. Corey and Brooks. Believe that, Brooks and Corey, exactly. You've heard of the equation. He's the one here who studied with the guys. And B.P. Workington at Oregon State University. Later, he had a productive postdoc under Dr. J.C. Parker at Virginia Tech. Afterwards, he largely worked for the U.S. National Laboratories, Pacific Northwest Laboratory, and Idaho National Laboratory. But spent 4 years at Sultan Qaboos. That's the way he said, Bob?
Yes, Qaboos, yes.
Qaboos University, and the Sultan of Oman as the head of the Soil and Water Department. He has given seminars on subsurface NAPO behavior over the years at many universities and institutions in the USA and internationally. Thank you very much, the three of you, and I hope I had a great introduction for you. You put a great job. Congratulations. Please make a short introductions of yourselves, why you pick hydrogeology for a life career, and why LNAPOs in general and DNAPOs, why all that. Thank you very much, guys. Welcome.
Sure. Yeah. Thanks, Everton. And maybe I can get started on that. So I like to tell people, you talked about the University of Waterloo. I was there as an undergrad. I like to say that I got into contaminant hydrogeology from the contaminant side, right? I was interested in pollution control. I was interested in chemistry. I started to get interested in environmental systems, but then I started to get more interested in these open, uncontrolled systems, and groundwater started to get fascinating to me. So then I did a little bit of work in consulting, and then that led me to a master's in DNAPL remediation, and then eventually a PhD in multi-phase flow, and just sort of fell in love with it. I mean, to tell you the truth, and I think anybody who has a chance to see these processes in the field or to see them in the laboratory, multi-phase flow and DNAPL and LNAPL, it's fascinating, right? So I stuck with it, and I'm still doing work in that today.
Very good, very good. Who's next?
Bernie, go ahead.
Bernie Cooper here. Thank you, Everton, for the wonderful introduction, and Kevin. I fell in love with groundwater during a second-year undergraduate work term. in Chalk River, Ontario, which most people listening to this interview probably don't know where that is. But we were in the field, and we were designing and building straddle packer assemblies and doing tracer tests in fractured rock. And I just thought it was the best thing in the world. I just fell in love with it, and I knew my path. It had to be groundwater. And I went to Waterloo, and here we are 32 years later.
Very good. Very good. Good for us. You, Bob.
Hey, hi, it's Bob Lenhart. I had a very tortuous path. Initially, I studied forestry and had an interest in forest soils. And when learning about water movement in forest soils, I was taught from the perspective that water behavior was a multi-phase process, not a single fluid as is taught in many agricultural courses. This prepared me to address the physics of the simultaneous movement of air, water, and NAPL when the serious health issues arose in the 1980s over the subsurface contamination of non-aqueous phase liquids. And I've been investigating subsurface NAPL behavior for almost 40 years.
Wow, this is very
Yeah, a
good.
long time.
Yes, yes. That's the bad thing. We're always talking about decades now, right?
Yes, the decades.
More
Very
years.
good, very good. So how was the idea of writing this book, and how you ended up teaming up for this project?
Yeah, so John Cherry approached me with the idea of writing a book on L-NAPL and D-NAPL flow, sort of for the early portion of the groundwater project, and I agreed. And then shortly after agreeing, I realized that that's not something you do on your own by any stretch of the imagination, right? I needed a team to be able to pull that off, and really wanted to go out and find world-leading experts, looking for one each on D-NAPL and of course one on L-NAPL. I've known Bernie for years and years, right? So that was a natural fit, right? International leader in D-NAPL, pioneering leader in D-NAPL, and reached out to him, and he agreed, which was fantastic. And then I'd read a lot of Bob's work during my PhD. And so Bernie and I got together and said, wouldn't it be great if Bob Leonard would agree to do this? So we called him. He said, yes, it was perfect, right? And so that's how we sort of pulled that team together. I don't know, Bernie, is that how you kind of remember it?
Oh yeah, absolutely. That's very accurate, Kevin. Yeah, thank you. And thank you for leading this, Kevin, on our behalf. Yeah, so I love this book because multi-phase flow is super important now, right? L-NAPLs, D-NAPLs, contamination remediation, we know that. And I've been teaching an undergraduate course at Queen's for over 30 years. And there are textbooks out there on multi-phase flow. We were talking about Julian's book earlier, Everton, right? But there's no one book that just kind of gets it together at the right level. So I teach from my own notes, for 30 years in this course. Now, this book was an opportunity for Kevin and me and Bob to put the story together in the way we think it needs to be communicated. So that's what I really like about this book.
I do too. Bob.
Okay, yes, I was, when I was approached, I thought it would be a great idea to join the team, especially since the book was going to be offered, to students worldwide through the internet, and the associated costs of students having to buy books. I thought this would be a great idea, and I was looking forward to contribute to it.
That's very good. That's very good. And we're happy that you teamed up for that. It's very, very interesting book. Very nice. I was, I used to teach here. I stopped 2 years ago. I used to teach multi-phase flow in my course for the grad students. And boy, we don't have a single book like this one that we can use as a textbook for people to start and learning that. And so it's bits and pieces. You know how hard it is. So I'm very glad you produced this material. So guys, L-NAPLs and D-NAPLs as multi-phase flow may be highly complicated, right? Even for understanding the concepts. Could you tell us how the book is structured, to guide us through the concepts?
Yeah, I mean, it is a complicated topic, but it's a topic that we all really love to teach. Right. So I think that we really were motivated to sort of lay it out and build those concepts kind of one at a time. So the book really starts off with an overview, right? Linking people to the kinds of chemicals that are non-aqueous phase liquids, right? Talking about gasoline and diesel as LNAPLs, talking about solvents, dry cleaning fluid, coal tar as DNAPLs, and starting to sort of describe, at least conceptually, how they move through the subsurface, right? That's where the book starts. And then for those that continue to be interested, we start to layer on the details, right? We start to talk about linking those physical processes to some fundamental sides of things, so linking into some mathematical expressions. So we introduce things that people might not be as familiar with. We start talking about capillary pressure, right? We start talking about interfaces, interfacial tension and wettability. We build that into relative permeability, right? To link up to what people probably know about single phase flow, but start moving it into two-phase and in fact some three-phase flow material. And all of that is relevant to both LNAPLs and DNAPLs, but we close the book with some specialty topics, right? And which are really driven by the experts, you know, Bernie and by Bob. I don't know, Bernie, do you want to talk a little bit about sort of the DNAPL portion at the end of the book?
Yeah, sure, Kevin, thank you. So DNAPLs, dense non-aqueous phase liquids, that was all of a sudden hitting us in the mid to late 1980s, and people realized with the the Superfund sites, now Superfund sites in upstate New York, and the birth of modern environmental regulations, these were a big deal, and that just hit us in the regulatory community and the research community in the 1980s and all through the 90s and still today. So yeah, DNAPLs are a big deal. It's a fascinating topic, as Kevin was saying. It's multi-phase flow. You got to understand two fluids. The DNAPLs can go that way. The groundwater can go the opposite way, right? And then there's all the dissolution, the plumes, and all this kind of stuff involved with it, which is all articulated in the book. I'll stop there.
Very good.
Yeah, and how I think the book was basically structured is in the first section of the book, we stress fundamental considerations involving multi-phase flow. In the latter sections, we apply these fundamental properties to the LNAPLs and the DNAPLs. And there's nothing special about multi-phase flow to be only LNAPLs and DNAPLs. Air-water systems also is multi-phase flow. So whenever you have multiple fluids in the subsurface, we stress all the principles and the properties that are involved.
Very good. So then how the unsaturated zone concepts help us understanding NAPL behavior then?
Well, it certainly helps to understand those saturated zone concepts because a lot of this starts with Darcy's law, right? And we need to extend on top of that to understand multi-fluid systems. You've really got these two different interconnected flow pathways with interfaces in between them, right? So as people learn the single phase flow, they'll start to understand driving forces and resistances, right? Hydraulic head gradients and hydraulic connectivity, but we need to extend that then to permeability and relative permeability. And so we build on those saturated, what Bob was saying, single phase concepts, but of course, multi-phase starts being applicable to a range of different conditions.
You guys want to add something? Bernie and Bob?
No, I think Kevin covered it appropriately.
Very good, very good. Well, then you mentioned the three fluid system. Why is it important for LNAPL or DNAPL understanding the three-phase fluid?
Bob, you're a three-phase guy. You want to take a shot?
Well, yeah, it's simply a three-fluid system occurs above the water-saturated zone and refers to air, water, and NAPL being present. And generally, it suggests that all fluid phases are continuous throughout the pore spaces and will move in response to pressure gradients in that fluid phase. Essentially, all fluids are mobile. Generally, all LNAPL problems involve three fluid systems and are important for assessing potential groundwater contamination. In the case of DNAPLs, where they penetrate into the water saturated zone, then you still get a multi-phase system, but then it's basically just dealing with two fluids. When you're dealing with three fluids, you're essentially talking about in the vadose zone above the water saturated area.
True, that's true. Good. Well, I use in my PhD, I use ethanol. That was the idea, ethanol to reduce the interfacial tension. and see if we can, mobilize the residual phase. And then, things got really complicated because ethanol has a density difference that is quite important. So we ended up having, those unstable.
Yeah.
We trying to bring ethanol down, but then the front became unstable. That was a hell to deal with. Very difficult, very difficult. It didn't work because of unstable flow. Yeah.
Like you asked about saturated zone concepts, and sort of Bob's question leads into, these unsaturated zone concepts can help you out with this as well, right? These air water systems are also multi-fluid systems, right? And so we envision our book as helping those concepts as well. Of course, most people that are interested in vadozone systems, those are quite shallow. The air tends to be connected to the atmosphere. So there's a few simplifications that have to be built onto that, right? But they all come from the same place. I think, interestingly, as hydrogeologists and contaminant hydrogeologists get involved in other gas systems that are deeper, think energy storage, climate, right? CO2, hydrogen. Actually, the systems in our book will start to approach what's needed for those gas water systems because they're not shallow anymore. Right. So there's saturated zone concepts, but as we've been talking about, these unsaturated zone concepts that also touch on this general topic of multi-phase flow.
Yes.
And even to all deep in CO2 injection to subsurface when you become supercritical fluids. Yeah. Also, it's a multi-phase system.
Exactly. That was my next question, because today we're having a lot of CO2 injection, right? And they're supercritical. They're not. People tend to think that they're acting as gases, and it's not exactly that, right?
Yeah. No one knows what a supercritical fluid is.
Yes.
There's no picture of one.
No, it's open for study. That's good for researchers, right? Interesting. So what about the mathematical treatment on the book? How much math do we need to profit from the book? Can we survive? Some geologists are scared from the beginning, but I don't think. But what's your opinion?
So I'll field that question.
Yeah, go ahead, Vern.
All right, thanks, Kevin. So the math in the book, first of all, math is involved in groundwater, in multi-phase flow. Math is math, right? So you can take from this book as much math or as little math as you wish. Okay, and there are some very simple algebraic expressions for a, critical height of DNAPL on top of a little lens before it can penetrate that lens, a capillary barrier, stuff like that. And there's also some partial differential equations, and it gets a little more complicated. So I look at any book like this. I mean, you take away as much math as you like, and if you get excited about the math and there's something about the math that you don't quite get, reach out to any of the three of us, please. And take a look at your calculus textbooks, take a look at your partial differential equations textbook, but that's not required. We try to reach a very broad audience in this book where you can take away as much math as you like.
I do agree. I read the book and I felt the same, Bernie.
Well, okay, good.
I have my basic understanding of math is required. Predicting the simultaneous movement of air, water, and NAPL is very complex and requires solving multiple nonlinear, partial differential equations simultaneously. Okay, but this level of math understanding is not required for the book. No. We only describe, the basics in the book. So any student shouldn't be afraid to dive into the material and learn from it.
I totally agree. What I have seen from the book that I liked it most is that the concepts are clear. You have nice illustrations and you have the concepts clear, and it is not easy to teach that. You have that experience, so that not everybody has, because you pick geologists, you pick engineers, they have different backgrounds, and then one information is missing for this crowd, and then the information is missing from the other crowd, and the book tries to put everything together, and I think you really achieved that. So congratulations! It was a very nice job you put together there. Thank you guys.
Thank you very much.
Who is the target audience of your book and why?
So this isn't intended to be the first book in the groundwater project that somebody would read, right? So we talked about some saturated zone, some unsaturated zone knowledge. That's advantageous.
Yeah.
We really structured this to be primarily an upper year undergraduate textbook. There are elements that will be relevant to introductory level graduate students as well, right? Depending on your background, like you said, if you got to fill some things in, but really it's targeted to that, third, fourth year undergraduate student with an interest in contaminant groundwater processes.
I agree. You guys?
Yeah, I'll go next. Thank you. Yeah, so, I mean, it's interesting. I'm in Las Vegas right now in my hotel room. And why am I in Las Vegas? I'm not a gambler. I'm in Las Vegas because I'm teaching.
Tell the truth.
I'm in the Princeton groundwater remediation course. It's the same audience that we're teaching here in Las Vegas this week with colleagues that Everton, and
Yep.
that are the target audience of our book. So it's regulators, it's consultants, it's site owners, and it's upper year undergraduate students as well as first year graduate students. I know that's a broad range, but that's where we've targeted this. And like we were just talking about, you take from the book what you like. And there are tons of references in our book. We cited all sorts of publications where you can dig deeper, whatever you wish to do.
True. Bob, you want to add something?
No, I agree with what Kevin and Bernie said completely.
Good. So I'd like to add that I believe that most of the concepts that you cover there in the book, you don't even need to be a third year student. If you don't care much about the math, like differential equations that you need some calculus at the beginning, you can survive easily with the concepts, and you can understand the whole thing by not having the deep math for the equations. Because some of the equations are just simple as any students can don't even need to be at college to understand, right? It's very that's true. I'm not saying that because I'm talking to you guys. It's very obvious. You can see and you can learn, because if you have the basic physics, you can get it. That's very, very nice. So
well, that's great. That's great to hear. Thank you so much, because we really did try to build that sort of conceptual, intuitive understanding into the beginning of the book.
I really believe you achieved that, because it's you have to have a deep understanding of that, in more so by having contact with students, because you see when they get it. You're explaining, you're looking at their faces. Today we don't see the faces on online courses, but presential courses, you see them, and then you do learn how to teach. And I can see that you achieved that on the book, which is very good. That's why I mentioned to you that I did miss your book when I was in my graduate student. That would be very handy. That would be very handy.
Because I think you're right, and you mentioned that when we were all doing our studies, to get at this kind of material, you had to search out a number of different sources, papers, a few chapters, and a few textbooks. And there's some great sources out there, but there are so many of them. There's very few that pull it all together.
Yeah.
Right. So when I teach, I think this is true of Bernie and Bob as well. We tend to teach from our own notes. We tend to teach from our own experience, and we really wanted to try to bring that focused approach to a single resource.
Yeah, I agree. And many people that working with remediation, they don't have that concept in place. Those concepts in place. It's amazing. That, right? So this book, I believe it's going to be, it's going to do a good work for many of, the professionals in the field. Oh, really? It's not the way it works. Right? Because people just dump you dump some peroxide or whatever in the field, and they don't even know how the residuals are in place, right? So that's going to be a great job, guys. I like a lot of your book, and I'd like you to make your final considerations about that. And thank you very much for participating in the Groundwater project. I hope you have some spare time to put more books together, because you're talented people, and I know your work, and I hope you help us more. And we'll do our part here, helping spread the existence of the book and telling people how good it is. And I hope it's going to be a huge success. I really enjoyed it, and I'm working hard to make it happen. All right. Thank you. Please make your final considerations.
Yeah, nothing really to add. Thank you so much. I think you really helped emphasize some of the key points that we wanted to come through in that book. So maybe just in closing, wanted to thank you for taking the time to do this and your help in reviewing the book. We know you were part of that, and obviously our thanks to the whole crew over there at the Groundwater Project. And on this call, I would just like to thank both Bernie and Bob. Like I said in my initial answer, this is not something you could ever do as one person. And so thank you to both of you for all your efforts. And it was great working on it. And I think it is a good book, and I hope it'll be useful to a number of people.
I'll add to that, Kevin. Thank you. Thank you, Everton. You are a champ, doing a fantastic job here. That's great.
You guys are
Good to
good.
see you again.
It's easy.
And,
My part is easy.
Easy. Yeah. I really appreciate it. I just want to close by saying I want to thank Kevin Mumford for leading the writing of the book. Somebody, we're all busy people. Writing takes time. And Kevin took the bull by the horns and did the first draft. And then Bob and I, of course, did our stuff. So Kevin, thank you very much for that. And I encourage people listening to this interview to pick up our book, or to download our book, I guess, and read it. Thanks, Everton.
Thank you very much, Bernie.
And I just want to thank all. Okay, and I feel we had a good team. We put together some works that you're not going to find in other books. So it will have a perspective of both the L NAPLs, the D NAPLs, and the fundamental considerations of multi-phase flow. So it was an enjoyable exercise.
Very good. Thank you very much, the three of you. Congratulations for a job well done. And I'm really happy to see that I'm a multi-phase flow guy too. And I'm, really enjoy that, because, I miss so much. Now I stopped teaching, you come with the book. It's a bit late, but that's okay. People will have fun. Thank you, guys.
Thank you, Everton.
Okay, bye now.
Bye.